Inverse variation, inverse. You will see the word inverse written. So exercise 1008. Inverse variation occurs when two variables change in different directions. That is, as one increases, the other decreases. And also, as one decreases, the other one increases. Now, if you look at, remember a few lessons ago, so these are some examples. If the time of journey and average speed, the faster you go, the less time it takes if you're driving, or the faster you walk, the quicker you'll get there. That's inverse. Air temperature and altitude of plane. You know, when you're in a plane, the higher you go up, the lower the temperature. As one quantity goes up, the other one goes down. And another one with internet speeds, the more users on the internet, the slower the download rate. Now, this is what the graph looks like. If we say y varies inversely as x, we don't write y equals kx, but we write y equals k over x. Now, if you remember these type of equations, these types of graphs are hyperbolas. This is like a hyperbola. For example, this was the y equals a over x type. For example, y equals 1 over x, y equals 2 over x, etc. This type of graph looks like this. As one quantity gets bigger, like for example here as x is getting bigger, y is getting smaller. All right? So this is the type of graph that is related to inverse variation. So which equation is an example of inverse variation? See this first one? That's really y equals x over 2, or y equals a half times x. So that is not. That's direct. That's direct. This is y varies as the square of x. That's the same as the first one, a half times x. This one is inverse. The x and the y have to be on different rows. One on the numerator, one on the denominator. Now, if I rearrange this equation, girls, what was if you know how I've got y equals 2 over x? What happens if what's the inverse of dividing by x? What's the opposite of dividing by x? Timesing. That graph could also look like this. Y times x equals 2, or x times y is 2. All of these are the same thing. So an inverse variation type graph or a hyperbola can also, instead of y equals 2 over x, for example, if the inverse operation of dividing by x is timesing by x, it could also look like this. X times y is 2. Now, girls, so as I said, inverse variation, which graph? That's straight line, so they're not right. They're straight lines. So that's not right. They're direct. They're direct, linear variation. What about this one? What shape does it look like, that one? Couldn't that be a parabola? That's like a squared. This is your hyperbola shape. Okay? As the x gets bigger, or as the speed gets bigger, the time gets smaller. So this is your inverse variation. Remember, your inverse variation is a hyperbola. Now, this question here, if the pressure P varies inversely with the volume, we go P equals K over V. Which one is correct? A, B, C, or D? That's our first step. If P varies inversely with the volume, P equals K over V. Girls, the K is in the wrong position. This is wrong. This is direct. This is direct linear variation. And this, we don't put pluses in it. We never put a plus. No plus. So that's your answer. This is the wrong way around. Okay, this type of graph where P equals K on V, that is a hyperbola type of graph, which is your inverse variation. But with your inverse variation questions, you won't see this quadrant 3 section of your graph. P equals KV, that's a direct linear relationship. that type of graph would look like that. And P equals K times V. That's really P equals V. It's also a straight line graph, but it's just shifted upwards. So that's also linear with a shift up. So, and this one is, that would also be linear as well. P equals V divided by K, but it would have maybe just a very small gradient or something, because the P and the V are on the same line, both. That's on the numerator, that's just divided by some constant. So this one is inversely. So here the pressure varies inversely with the volume. So P on the numerator, V on the denominator there. Now for question 4, the frequency F in beats per second that a bird beats its wings varies. So F varies inversely as the length L. So F equals K over L. Okay, so you don't put K times L, it varies inversely, so it's K over L. Now a bird with wings of length 14 centimeters, so if L is 14, then the frequency is 8 beats per second. So substituting that in to work out the value of K. So we've got 8 equals K over 14. So therefore 8 times 14 equals K, or K is 112. So therefore the formula is F equals 112 over L. So that's our formula. Now part B, calculate, correct to the nearest whole number, the wing beat frequency for wings of length 18 centimeters. So if L is 18 centimeters, we're trying to find out the frequency. So using the formula, F is 112 over L. We've got that F is 112 divided by 18 is 6.2 recurring centimeters. We need it, frequency, that's not in centimeters, that's beats per second. We need it to the nearest whole number, so it's 6 beats per second for the frequency. And now for part C, a bird beats its wings with a frequency of 4.5 beats per second, so the frequency is 4.5 beats per second. What is the length of its wings? So the formula is F equals 112 divided by L. So we've got that 4.5 equals 112 divided by L. Now, so a quick way of doing this is to swap across the equal sign. The L goes there and the 4.5 comes down here. Or the inverse operation of dividing by L is to times by L. And then to get L on its own, the inverse operation of multiplying by 4.5 is to divide by 4.5. But now, if you compare this line that I've got here with that, we can see the L and the 4.5 have been swapped. So 112 divided by 4.5 is 24.8 recurring, which is 25 centimeters, the length of the wings, to the nearest centimeter. Okay, question 7. The amount of time it takes Sarah to move house is inversely proportional to the number of friends. So time is inversely proportional to number of friends. So we go T for time equals K over F, number of friends. Now, so inversely proportional is K over. So when she has 4 friends, so if F is 4, or we can say when F is 4, the time is 3 3/4 hours, which is 3.75 hours. Okay, so substituting those into the formula to find K, we've got that 3.75 equals K over 4. Inverse operation of dividing by 4 is to multiply by 4. So K equals 3.75 times 4. So we have that K is 15. Now, this is just to establish that the formula is T equals 15 over F, because we know that T equals K over F and that K is 15. So that's our formula, T equals 15 over F. Now, question part A still, how long will it take if she has 6 friends? So when friends is 6, we have to find T. So we've got that T equals 15 over 6, which is 2.5 hours. Make sure you're putting in the units. And now for part B, how many friends must she have to help her move house in 3 hours? So if the time is 3 hours, we have to find the number of friends is question mark. So again, T equals 15 over F. So 3 equals 15 over F. Again, we can do that swap diagonally, or we can do the 2 steps. So inverse operation of dividing by F would be to times by F. So 3 times F is 15. Here we can already see that F is 5. Okay, so F is 15 divided by 3, which is 5. So it's 5 friends, okay, if it's going to take 3 hours. Now for question 11, 2011 HSC question 28A. The air pressure P in a bubble varies inversely with the volume. So P equals K over V. So P varies inversely with the volume V. We have to write an equation relating P, V and A, where A is the constant. So we're actually not using K this time, we're using A. Okay, so we're replacing the K with an A. Now part 2, okay, so I've just got replace K with A. Now part 2, it is known that P equals 3 when V is 2. So P equals 3 when V is 2, we're going to find A. So we've got P equals A on V, so we're using this formula here. So I've got 3 equals A over 2. So we can see that 3 times 2, inverse operation of dividing by 2 is to times by 2. 3 times 2 is 6. So therefore the formula is P equals 6 over V. Now we can answer our question by finding the value of the constant A, which we have. Find the value of P when V is 4. So when V is 4, we've got P equals 6 over 4. In other words, P equals 1.5. So there are no units on this question, so we can't give any units. Now, for part 3, it says to sketch a graph. 3 says to sketch the graph to show how P varies for different values of V. And it says use the horizontal axis to represent the volume and the vertical axis to represent the pressure. So vertical axis is the pressure P and the horizontal axis is V, the volume. Now we already have some values here. We know that P equals 3 when V is 2. So I'm just going to put some values here. So they both go up to 6. We've got 0 there. Now remember, we did spend time, this is this sort of curve is of the form, the curve, so P equals 6 over V is of the form y equals, so it's really like this, y equals 6 over x. Now that is a hyperbola. Now we know that a hyperbola is in 2 sections like that and like this. However, we're not going to be using this section here with negative x values. So we can use this formula here, or we can substitute from there. So I'm going to use the formula here. When V is 1, 6 divided by 1 is 6, so the pressure is 6. When V is 2, 6 divided by 2 is 3. Just can do a little table of values. V and P. Now I'm just going to put when P, I'm just going to leave a space there for a minute. So when P is 1, when V is 1, P is 6. When V is 2, P is 3. When V is 3, 6 divided by 3 is 2. And I'm going to do when V is 6 because I'm just finding numbers that divide easily into 6. 6 divided by 6 is 1. So I'm going to plot those. So the 0.16, the 0.23, the 0.32 and the 0.61. Now we do expect it to be this shape and we must put arrows on the end. I'll just move that P. So this just keeps going up there. Now it will never touch both the P axis and it will never touch the V axis because it'll look like that. Remember that the V axis and the P axis are both asymptotes. So that is the sketch of the curve. Please put arrows on the ends. And you do not want it cutting either the X, the y-axis, which is the p-axis, or the v-axis, which is the x-axis. So the shape is a hyperbola. But we only want the quadrant 1 section of it. Now the last question here, 2012 HSC, question 15. The time taken to complete a journey varies inversely with the speed of the car. So T varies inversely with speed. So T equals K over S. And a car takes 6 hours, so time is 6 hours to complete a journey when traveling at a speed of 60 kilometers per hour. So we're going to substitute those in. T is 6 and S is 60 to find the value of K. So 6 equals K over 60. So therefore 6 times 60 is K. In other words, K is 360. So therefore our formula is T is 360 over S. Now, so this is our inverse variation formula relating T and S. Look, sometimes you can see this written as, so T equals 360 over S is actually the same as, if I, inverse operation of dividing by S is to multiply by S. So sometimes you can see, if you ever see an equation written like this, like I said, inverse operation of dividing by S is to times by S. If you ever saw TS is 360, T times S is 360, it's exactly the same as that. Okay, so those two are exactly the same equation. But, you know, we're not going to need that for this question. So we've got T equals 360 over S. Now, the last question is, the question says, how long would the same journey take if the car was traveling at 100 kilometers an hour? So if the speed is 100 kilometers per hour, find T. So T equals 360 over 100, which is 3.6 time in hours. That's 3.6 hours. Now, 0.6 of an hour, 0.6 hours is the same as 0.6 times 60, which is 36 minutes. Look, the other thing you can notice is that 0.5 of an hour is 30 minutes. So 0.6 of an hour is going to be more than 30 minutes. So the time is 3 hours and 36 minutes. And that is option D in the multiple choice answer. So please don't put 3.3 hours 6 minutes, because 0.6 is bigger than 0.5 and 0.5 of an hour is 30 minutes. So you need to convert your hours into minutes, because we know that there are 60 minutes in an hour. So 0.6 hours is 0.6 times 60, which is 36 minutes. That's the end of our inverse variation questions.